Hello again everybody and welcome back to Steam Code. In the last video we took a look at how to make each cell the cell class, which is basically representing each cell that we're going to have in our project. So in this video we're going to be taking a look at how to actually make the grid of cells and how to add the grid to the JFrame so we can actually see those buttons when we're running our project. So let's go ahead and do that right now. We're going to create a new class. We're going to call it grid. Okay. This grid class, since it's going to be holding the buttons, we're going to make it a J panel. So if we take a look at again with the cell class, each cell was a button. Well, the grid is going to be a J panel. So what we're going to do is we're going to click extends, and we're going to say J panel. Okay, so this grid is going to be a J panel, and make sure that you're importing the proper classes as well. Alright, so we're going to create a couple of variables here. So the first one is going to be a private integer, and it's going to be bound, which is basically going to be the maximum position, right? The max number, the max amount of cells that we're going to have. So bound is going to be 100 in this case because we have 100 cells. And the way we're going to get to that is we're going to say game.grid size. Remember, grid size is 10. It's going to be a 10 by 10 grid, so we can multiply game.grid size by itself to get 100. Okay. Next, we're going to create a couple of array lists. So we're going to do the first one is going to be a private array list of integers, and this is going to be mine. It's going to be called mine. This is going to be the position of each mine in the grid. Okay, so the mines is going to be holding the integer positions of each grid in the game. Okay, we're going to put this in as integer. Okay. Next one is going to be, this one's going to be a public static array list, because we want to be able to access this array list, which is going to be a cell array list. It's going to be called cell grid, and basically what this is going to be an array list that's going to hold every cell that's in the grid. And we want to be able to access this from anywhere without having to create an instance of our grid class, because we only want to have one instance of our grid class. So this is going to be a public static array list cell array list called cell grid that's going to hold cells inside of it. Okay, let's go ahead and move on to our constructor, and we're going to create two methods here. So we're going to call the create cells method, which is basically going to create instances of each cell, and then from there we're going to go ahead and add those cells to the actual grid itself. Okay, so we're going to create or call another method called add cells. All right, so let's go ahead and create these methods now. So public void create cells. Now, the first cells we're going to be creating are going to be the mines, right? Because we want to make sure we have those first, so that making other cells are going to be easier to do when we have our mines already picked out for us. So what we're going to do is we're going to go through and we're going to create 10 mines. Remember, because our mine count is 10, we set that here. So we can just go ahead and call our static variable here. So for int I is equal to 1, and while I is going to be less than or equal to our game.mine count. We're able to do this because, again, game.mine count is a static variable, so we just call game.mine count, and that's how we reference our static variable. we don't have to create, like, for example, a new game and then call or then look for a function that does that. We're able to just access it right here. And it's a final int, so we're not going to be able to change it or anything like that. So this will make it a little bit more easy because we're going to be referencing these kind of values a lot. So we're going to do while I is less than game.mineCount, and we're going to be incrementing by 1 every time we go through this loop. Okay. Now we're going to be creating a random number when we're going to be finding the best place for our mine. So we're going to go ahead and cast this number to an int. And we're going to say math.random times bound. Okay. So this math.random is going to return a float, and we want to cast this to an int. So the way we do that is we make this float an int by putting in parentheses int, okay? Because our mine position is an integer itself. So we want to create, otherwise it's going to give us an error, for example, right? This is going to return a float, and we're not going to be able to do that. So we have to say int math.random times bound. And this times bound is basically going to allow us to make a random number between 0 and 99. So that's going to be the index from index 0 to index 99, which is going to be 100 total cells. Remember, this is an index, which means we're starting at 0. Okay, then we're going to need to check to see if the random number is a duplicate random number, right? Because we don't want to have two mines in the same place, because then that'll create problems for us. So we're going to say if not mines dot contains. That'll basically look to see if we have this number called mine position. It'll say if that number is contained in our mine array list. Okay. So if that's not the case, that means we have a unique value. Then we're going to say mines dot add mine position. Okay. Then so the deal with this, right? We're looking at this. We're saying create cells. We're going to be going through this 10 times, but if we go through this 10 times and we create a duplicate cell or a duplicate mine, that means we're not going to end up actually having all of our mines that are actually that we need to have. Because if there's a duplicate, that means we might be creating nine mines instead of our 10 that we said. So what we need to do is we're going to need to create a new private boolean called picked, and we're going to create that, call that false. And essentially what we're going to do is we're going to keep creating a new random number until the random number is unique. Okay, so it's basically going to ensure that we're not going to be picking any duplicates or anything like that. We're just going to make sure that we have 10 unique mines. Okay, that's what this while loop is going to do for us. All right, so I'm going to put that there, and we're going to set picked equal to true if we actually do end up making sure that we picked actually an actual mine. Then what we'll do is after this, then we'll say picked is equal to false. So we're going to reset that and then go back through the for loop again over here. All right, so we just created we just assigned random values for all of our mines. Now what we're going to do is we're going to actually create cells based off of what we have, the information that we have here. So this next part is going to be, we're going to have a lot of for loops, a lot of if statements, a lot of things here. So if it does get confusing, I'm going to try to explain it the best I can, but if it does get confusing, make sure that you ask in the comments. I'll try to respond to everyone who does have a question. So, but I'll try to explain it here. So what we're going to do is we're going to say for int I, which is basically going to be our index, equals 0, while I is less than the bound, which is 100, right? So from 0 to 99, remember that index that we were talking about from 0 to 99, what we're going to be doing is we're going to be looking at our index and deciding what kind of mine or what kind of cell we're going to be adding based off of the index that we have and based off of whether or not there is a mine on that index. Okay, so if mines dot contains I, so if that index is in our mines. So basically we're checking to see if that is a mine. Then we're going to be creating cell grid. We're going to be adding that's a new cell to this array list. So cell grid.add, we're going to be adding a new cell. And the type is going to be 1. Remember, because over here our types, if it's a mine, it's going to be type 1. So we're going to be creating a type 1 mine, or a type 1 cell. The position is going to be I, and the rest is going to be false. So false, false. Okay? So we just created if I is equal to the integer or the index of the mine, then we're going to be doing that. Now for all other circumstances, we're going to be checking to see if it is a blank mine or a blank cell, or if it is a cell that has a number on it. And remember, number cells mean that there is a mine adjacent to it on either the corners or on the sides. So let me illustrate what I mean here. What we're going to be doing here is we're going to be seeing if there is a mine. Say we're looking at index number 35, right? We're going to need to see if there is a mine over here, if there's a mine over here, 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 or any of these spots. If there's a mine in any of these spots, that means that we're going to need to make this a number cell, which is going to be type 2. Okay, if it's not, if there's nothing next to this cell that we're checking, then basically what we're going to do is we're going to create a type 0 cell, which is just going to be a blank cell, right? Okay, so let me just do that. So the way we're going to do that is we're going to look to see this cell, right? So this cell, the index of this cell is 24, right? Okay, you remember the way we're going to do this now? You remember we had our game.grid size, which is equal to 10. So what we can do is you can say this index, which is 35, minus 10, which is 25, minus 1, which is 24. So to check this cell, we're going to be saying basically I, which is 35, minus game.grid size, which would be 25, minus 1, which is 24. Then we're basically going to do that for this one, but you're going to change up the numbers a little bit. This, which is 26, this is 34, this is 36, this is 44, this is 45, and this is 46. Okay, so we're going to be checking each of these adjacent ones to see if there's a mine next to it. If so, it's going to be type 2. All right, so let's go ahead and do that here in the code. And again, if this is confusing for you, please make sure you let me know in the comments. I'll try to answer any questions that you have. So we're gonna do else for right now. We're gonna just have an else statement, and we're gonna say if mines.contains that I position, that index that we're currently at, minus game.grid size minus 1. This is the one to the left and above it. Okay, so if that is a mine, or if mines.contains I minus game.grid size, that's the one directly above, and we can just copy and paste what we have here. So we do this, or do this. Okay, so that's the one directly above. Then we're going to look at directly above to the right, which would be plus 1. Then the one directly just to the left of the one we have, which is just going to be I minus 1. This is going to be I plus 1. This one is going to be I plus I plus game.grid size minus 1. That is to the bottom and to the left of the one that we're looking at. This is going to be I plus game.grid size, which is the one directly below the cell we're looking at. And this is going to be I plus grid size plus 1, which is below and to the right. All right. Now, if any of those are mines, right? So we're checking to see if any of these adjacent ones are mines. Then we're going to be creating a new cell in our cell grid array list. Okay, so cell.add new cell, and the type is going to be 2, right? Because that's a number 1, and then false, false. All right. Now, if that's not the case, then we're just going to be creating a blank cell. Dot add new cell, and this is going to be type 0. I false, false. Okay, so this is what we have here. Okay, so this is basically going to check every adjacent cell to the one we have to see if there's a mine there, or to see if the mines array contains that index. Okay, now there can be a slight problem, because what can happen is that, as you can see here, if there's something on the right or the left edge, it can detect that there is a mine on the opposite edge and it'll say that it's adjacent, but it really isn't, right? If there's a mine here, this what we wrote, the code we wrote could say that any of these have an adjacent, mine to it, which isn't the case, or any of these have an adjacent mine to it. Okay, and that can create problems in the future when we're trying to code this. So what we're going to need to do is also add conditions for the edge cells. Okay, so what we'll do is we'll see if we're going to put an else if statement here, so we can copy this, we'll just paste it here like that and like that. So we're going to see else if this is going to be for the left edge. So if we'll do I modulo game dot grid size is equal to 0. All right, so the modulo operator is basically going to be the remainder operator. So for example, if we do 2 or 5 modulo 2, we know that 5 divided by 2 is going to be 4, or is going to be 2. But the remainder is 1. So it's going to be 5 divided by 2 is 2 with a remainder of 1. So 5 modulo 2 is going to equal to 1. It's going to be equal to 1 because it looks for the remainder of what we have here. So basically I modulo game.grid size equals 0. If that's the case, that means that is on the left edge of what of the grid. Okay. We just need to now check to see if we're going to be checking. Hold on, let me pull this up. So now this is going to check for the left edge. So we only need to check, for example, if we're looking at this one, we're only going to need to check these adjacent ones, right? We don't want to be checking anything on this left side here, right? So we only want to check these cells that we have here on X. So what we're going to do is we're going to have the exact same code here. We're just going to be removing a couple of lines of code. So for example, this one we're not going to need, right? Because that looks to the top and to the left. We don't want anything that looks to the left. So we're going to remove this, and we're going to remove this line of code, and this should be fine. Now for this one, we're going to say if I modulo game dot grid size, if that equals in this case it will be 9, but we want to make it so that we don't have to change these variables. So we're going to say game dot grid size -1. Okay, that's going to check to see if it's on the right edge. All right, and I keep forgetting to do that. Okay, now if that's the case, we're going to just need to be removing these lines of code here. All right, we don't want anything that looks to the right side. Now this should complete our entire grid class, or our entire method called create cells in the grid class. We're adding to our cell grid new cells based off of where they are in the grid in relation to the mines and everything else. All right, so that's basically, we've just created all of our cells. Now it's time to actually add them to our grid. Okay, so we're going to go ahead and create our add cells function here. This will be a private void add cells, and we're just basically going to be looping throughout our entire cell grid and adding that to our JPanel. So for int I equals 0, while I is less than cell grid dot size, or this basically iterates through our entire cell grid array list. Okay. Then we're going to add to our JPanel. Remember, this is a JPanel class, so we just need to say add cell grid dot get I. Okay, so we're adding all the buttons that we have here. We're adding all these buttons to our array, to our JPanel. Okay, that's what that's basically going to be doing. Now, that should complete our grid class that we have now. Now we just need to add this JPanel that we have here. We need to add this JPanel to our window. All right. So if we go back to our window class, what we'll need to do is say JPanel is we're gonna be equaling that to a new grid, right? And what we're gonna want to do is we're gonna want to have a 10 by 10 grid. So the way we'll do that so that the formatting is gonna be correct, we're gonna be adding a new grid layout, and we can pass that as a parameter into our grid class. This will just make sure that our grid is going to be formatted correctly. All right. Now we're going to need to add that constructor. Add that to our constructor. So we'll say grid layout G, and then super class. So we'll say super G, and that'll just put that there. We look through all this code, and if you run it now, we run it, and oh, there's an issue. The reason for that is because we actually haven't added our JPanel to our window. So we'll say frame that set content pane, and we're going to set up the panel. Okay, so that'll basically add our panel to it. Then we're going to say frame dot pack. That'll make sure that everything is formatted properly. Now when we run it, we should have our buttons, and our buttons are able to be clicked on and everything like that. Now there is no functionality right now. In our next video, we're going to be going into that a little bit and talking about what happens when we actually click a button, and how we're going to be handling that. So until then, if you have any questions, if you have any comments, leave them in the comment section below. Until then, I'll see you in the next video, and thanks for watching.